All right, so if we were to take a concentrated solution, and say we had 4 molecules of, say this is a sugar solution, 4 molecules of sugar, and we started with 2 liters of that, and we diluted it, putting 3 more liters of water, meaning 5 liters total. How many molecules of sugar do I have? 4. So the number of molecules did not change, just the solvent changed. Okay, so if that's true, then the mole of the initial solute equals the mole of the final solute. Okay? So the only thing we're changing again, so if we start with 1 mole of sugar, we're going to end with 1 mole of sugar. What's going to change is the solvent. Now, there is something in dilution solutions, an equation you need to put to memory, needs to be sizzled onto your brain. And that is, if we have moles per liter, in other words, we have concentration, and we multiply that by volume, what do we end up with? What cancels? Liters, exactly. So we end up with moles. So whenever we have concentration and we know the volume, we know how many moles we got. Now it's imperative that you understand moles is the name of the game once again. Okay, so getting back to here, we're going to be using this to find the initial number of moles. And then we need to figure out the final number of moles. And we set those equal to one another because moles initial equals moles final. So this is the equation we're working with. We've got the initial volume times the initial concentration equals the final volume times the final concentration. How many variables are there? 4. So that means I have to give you 3 of those bits of information. It could be, 2 of them could be initial volume, final volume, initial concentration, and then you can calculate final concentration. Or if you know final concentration and the 2 volumes, you can calculate initial concentration. Okay? So, know this relationship. Okay, so let's take this example here now. Let's start with concentration is going to be, let's say, 5 moles per liter, 2 liters of water. I should say, let me back up, 2 liters of solution. Over here we have, and we want to dilute this down to 2 moles per liter. Okay, so let's Okay, so our final bit of information is we want 5 liters of 2 molar sugar. Say it's a sugar solution. How many liters of the concentrate do we need to start with? Let's say we have as many liters of the concentrated as we need. So let's say we have a whole bunch of the concentrated stuff. How much do we need though to make that 5-liter 2 molar concentration sugar solution? Okay, so we've got, now this is a dilution problem, right? We're diluting a concentrated starting material to the diluted final concentration. Okay, so we've got our equation just like this here. So we've got the initial volume, question mark. Concentration, we know initial concentration is 5. We know the final volume is 5 liters at 2 moles per liter. Okay, so we just set up a simple algebraic relationship. So we have now the initial volume is how much we take of the concentrated stuff and put in the diluted stuff. That's what V sub I is. So what V sub I times okay, so this is the concentrated dilute. So we have a simple algebraic relationship. We just solve for V sub I. So moles per liter cancels, we're left with liters, which is good. And we just solve it. Okay. So we end up with, can we do this without a calculator? Yes, we can. What cancels? The 5s cancel, exactly. So what are we left with? 2. So we need to, so the instructions are, we take 2 liters of the concentrated, and then we want 5 liters total. So how much is we added? How much water do we add? You say 3 to bring it up to 5. Now we have 5 liters of 2 molar concentration. So the directions. So those are directions. Now on the test, I'm going to ask you for directions. So the first thing you do is you do the calculations, then you write a little tiny paragraph to describe how you would mix this stuff. Okay? Do these make sense? Okay, so let's do another one. Okay, how to make 457 liters of 234 solutions of HCl from concentrated solution of 12.45 moles per liter or molar. Okay, first identify what's the concentrated one and what's the dilute one, okay? Well, this is the concentrated one. And these two are the dilution ones, or the final volumes and final concentrations. So we set up the same exact equation, this guy here. VC equals VC. Okay, so VC, we don't know. We don't know how much of the concentrated acid. So that's the unknown. So we're going to leave it as that. Volume of the concentrated acid times 1245 moles per liter equals dilute volume is 457. So this is V dilute and concentration of the dilute is 234. Now you can leave it as moles over liter or just molarity. I'm doing moles over liter, so it's obvious how the liters cancel. Okay, so that's your setup. Now we're just going to solve how much of the concentrated acid do we need? Okay, so we have 457 liters to 34 moles all over 1245 moles per liter. Okay. Units, moles per liter cancels, leaves us with liters of concentrated acid. And that is in liters too, not milliliters, but liters. Okay, we're looking at 3 sig figs for the answer. So that's going to be 859. How many milliliters is that? How many milliliters are in a liter? 1,000. Remember, 100 cents in a dollar. So remember, the centi refers to 100. So that's going to be we wanted to convert it to milliliters. So that's 859 milliliters. Right? So the directions. Okay, so we're gonna add 859 milliliters of concentrated HCl to how much water? How much water do we need to dilute it? How do we find that out? Okay, our final concentration, including the water, is 457. And we're adding that though, 0.859 liters of concentrated liquid. So how much water do we need? How do we find that out? Yeah,
Subtract the 859, maybe 4.57.
yeah, exactly. So we need to. So the final concentration is 470, 457. We want to subtract the 0.859 liters. And that is okay. So we do the subtraction, that's 371 liters of water we're going to add. So now our total volume of solution is going to be equal to 457. Part of it is going to be the 859 concentrated acid. The remainder is going to be water. Okay, so you're going to have on the test grams calculations and dilution calculations. Now I've got some worksheets for you if you'd like some more practice. I know some of you really like extra practice. Okay, so lots of practice with answers always. So there's at least 6 or 7 molarity worksheets, dilutions worksheets. Now, we haven't talked about titrations yet or absent and basis, but there's worksheets for that too. Okay?
Class.
Hmm.
What class?
There's a bunch of them there. All of them say molarity. So there's what? At least 5 or 6. Then there's also 2 on dilutions as well. Okay, this is a slightly different version. Okay, here we have certain concentration of sodium chloride, salt. I'm going to dump in some water. What's the final concentration? Now, last Saturday, we dumped in extra salt. See how that changed. Here we're gonna add, we have a solution. We're gonna add in extra water. What's the new concentration? Now, this is also a dilution problem because we're diluting the initial solution. Okay, so this is what's the final volume of water of the solution? So that's the final concentration. Same equation. Okay, so we've got 233 liters times 678 molar. So this is initial. Final volume is 545. We don't know is the concentration of the final dilution. So we solve for concentration, final concentration. So that's going to be okay, so liters cancel. Notice concentrations left over. So that's our final concentration. So we went from 6 down to 2. Basically, a dilution problem. Just different parameters are missing. Remember, there are four variables. You need to know 3 of them to find the 4th one. Okay, so this is different. Okay, so I'm going to do another problem. It's going to be a little different. We're going to take 2 solutions and dump them together. I'm going to figure out the final concentration. So you have 2 solutions of, let's say, salt. Okay, so solution 1 has got solution 2 has got and then we're going to dump and put them together. So concentration now, remember, is moles per liter. So we've got moles of salt on either side in both solutions 1 and 2. So we've got to add the moles for each one of those to find the total moles. So this is going to be total we're having total moles, total volume. Okay, so what's the total volume? Well, we're going to add 232 to 456. Okay, so our total liters is going to be 688. Moles. We've got to calculate moles for each one, then add them together. So number 1 is going to be 232 liters times 340 concentration. Solution 2 is going to be 456 liters times 245 concentration. This will be moles of 1, moles of 2. Okay, I jacked up the sig figs one. If I round too often, you're gonna get rounding errors. So I'm gonna try to keep as many sig figs as reasonable. Okay. We're gonna add these up. Okay, we've got 1906 total moles. So we define what is per liter. I'm gonna go 19 divided by the 688. So does this make sense? Okay, so if I take a 3 molar solution and dump it into a 2 molar solution, the new concentration is going to be something in between 3.4 and the 2.45. Can't be outside of that. Got to be within it. We ended up with 277, right? Yeah, 277. So that falls within that range. Okay. Now this is a lot trickier problem than the other ones. Okay, so let's, for the last example today, now this is problem is going to be a combination of last week dry ingredients and this week's dilution combination. Okay, so here we have dry, wet. So we're going to calculate the moles differently for each one. The dry is different than the wet one. Okay, so the first thing, let's do the dry one first. Okay, so we need to know the molar mass for sodium chloride, which is 5844. Where do we find that from? Periodic table. All right. Okay. So we have 334 grams. Okay, so that'll be the moles. Okay, so that'll be the moles. from the dry part. Actually, these are both dry. So we're going to add these together to get the total moles. Okay, so that's how many moles we have of sodium chloride. How many, what's the volume? Okay, we've got 232 liters and 456 liters. So what is that? 688. Okay, let's see this. Okay, so that's we have two solutions that started with dry ingredients, dumped it all together. Now let's do, are any questions about this? Driving force in this is concentration is moles per liter. So you got to come up with moles on all the parts of the solution and then find out your volume on all the parts. That's the essence of doing these type problems. Now this one's going to be tricky. Should say trickier. Okay, so we've got a solution of sodium chloride. And a solution of potassium chloride. So if I asked you for what are the moles So what are the moles of the sodium ions, the moles of potassium ions, and the moles of the chloride ions? Dumping these two solutions together. All right, first of all, what's the common ion between sodium chloride and potassium chloride? Chloride. So the chloride moles are going to come from two sources, not one, from the sodium chloride and the potassium chloride. And then this potassium is separate, sodium separate. Also, so when we dissolve sodium chloride in water, it splits up into sodium ions, chloride ions, potassium ions, chloride ions. So here, this is where we have to find that. So if we know the moles of this, that gives us, because it's a 1-to-1 from the balanced equation, that gives us moles So once we know the moles of sodium chloride, we know the moles of sodium, and we know the moles of chloride. Again, 1-to-1 from the balanced equation. So let's calculate moles of all this stuff here. All right. Okay, so we got 288 moles of sodium chloride, which equals 288 moles of sodium, 288 moles of chloride. Likewise, for the potassium version. Okay, so now we have the moles of each one, all three. And we need to add these two together, the chloride, common ion. Then we need to find the final volume. Final volume is going to be 123 and 212. So what is that? That's 3, 5 liters. Okay, so let's look now at concentration of sodium ions. Remember, square brackets is the same as molarity. Okay, so we have sodium is 288 moles in 335 liters. Okay. We do the same thing for the potassium. Okay, that's for potassium. And then lastly, the chloride. Remember, the chloride comes from two sources now. So, okay. Okay, so this is probably as hard a problem as you're going to see in this class. We're mixing solutions. When you get into acid-base chemistry, we have an ion that's common to both solutions. It's called the common ion effect. That comes into play in acid-base chemistry. All right, so are there any questions about this one? We have two sources of chloride, so we need to find each one that add them together. We've got the sodium solution, we can find the moles of sodium chloride, which is the same as the moles of sodium. Moles of potassium chloride, same as moles of potassium. Okay. All right. Okay, so that's what I wanted to cover today on solutions. Lots and lots of mole stuff in there, you can say. Now, tomorrow we're gonna start on acids and bases. And again, acids and bases are solutions again. So our solution chemistry is gonna come into play with our acid-base chemistry. But first, we need to learn what an acid is, what is a base, how is it measured, etc. All right. So lab today, you guys are gonna like double replacement reactions. Make sure you do your pre-lab for it.